Hello student, welcome to my channel Learn Physics. Today I will be discussing the main this paper. This discussion will be extremely helpful for you to tackle the MCQ in next entrance examination. I have already uploaded the one-shot videos of NCRT of each chapters. I give link in the description. You can watch this video. This video will be extremely helpful to solve the MCQ in main, NEET and advanced. So let's start. First of all, question number 1. A force is applied to a steel wire A rigidly clamped at one end. As a result, the elongation in the wire is 0.2 millimeter. If the same force is applied to another steel wire B of double the length and diameter is 2.4 times that of the wire A, the elongation in the wire B will be. Okay, look at this. The given conditions are elongation of A L1. This is the 0.2 millimeter. Okay, length of L1, length of A is L1 equal to A. Area of cross section R1 equal to R. Now we have to calculate the elongation of the wire B. Look at this. Suppose this is the L. Length of B is equal to 2L and radius of cross section R2 equals to this is the 2.4. Now we know the elongation directly proportional to length of the wire and elongation also inversely proportional to 1 of, look at this is the R square. Okay, so look at this, we can write L2 by L1, this equals to, this is the L2 by L1 and this is the R1 by R2 whole square. Okay, no problem. Now this can be written as this is the 2L by L, okay, plus this is the R by 2.4 R whole square. Okay, no problem. Now look at this is the 2 into, look at this is the 1 by 2.4 whole square. Therefore L2 equals to, look at this is the L2 equals to L1 0.2 millimeter into 2 divided by this is the 2.4 into 2.4. Okay, now this and this cancel out, this is the 12. Now this and this cancel out, this is the 6. Therefore this is the, look at this is the 1 by 14.4. Now 1 by 14.4, so look at this is the 100 into 10 to the power minus 2 divided by 14.4. Now 14.4 and this is the 100. So look at this is the almost 6.9 into 10 to the power minus 2. So look at this, option A is correct. Okay. Now question number 2. An object is allowed to fall from a height r above the earth's surface, where r is the radius of the earth. Its velocity when it strikes the earth's surface, ignoring the air resistance, will be. Look at this. Suppose this height is the earth. This is the height r. A, a body is fall from this height. So here kinetic energy at this point will be 0. Potential energy at this point, suppose this is the U1 minus G capital M small m by distance of this point from the center of the earth. Now radius is r and height is r, so this is the 2r. Okay, so at the top point potential energy is minus gmm by 2r and kinetic energy k1 equal to 0. Now on the earth surface, look at this, on the earth surface potential energy U2, this equal to minus G capital M small m by distance from the center, this is the R. Kinetic energy K2, This equals to half mv square. We have to calculate v. Now, using conservation of mechanical energy, U1 plus K1 equals to U2 plus K2. Okay, now U1, this is the minus G capital M small m by 2R. Okay, and kinetic energy 0. Now here potential energy minus G capital M small m by R plus this is the half mv square. Okay, no problem. Therefore, from here half mv square equal to, look at this, G capital M small m by R. Now this is the 1 minus half. Okay, so from here half mv square, this equals to, this is the G capital M small m by R, and this is the 1 minus half, this is the half. Now this half and this half cancel out, small m cancel out, so V becomes, look at this, root over of Gm by R. Now you know Gm equal to Gr square. Okay, therefore if we put the value of Gm here, we can get, look at this, this is the Gr square divided by R. So Gr is the velocity at the earth surface. Now look at this, B option is correct. Okay, understood. Next. Now question number 3, match list 1 with match list 2. First of all, look at this torque. The dimension of torque is ml square t minus 2. Okay. Now look at this. This is the ml square t minus 2. So this is the A. Okay. Now look at this. Energy density. Energy density means pressure. This is the ml minus 1 t minus 2. Look at this. This is the B. Okay. Now look at this. B has two options, or B1 has two options, 1 and 3. Now look at this C, pressure gradient. Look at this, pressure gradient means pressure by length. So look at this obviously this is the C. Therefore look at this, B4, B1, C2 is the correct option for question number 3. Okay, next. So now question number 4. An electron is accelerated through a potential difference V1, has a de Broglie wavelength of lambda. When potentially changes to V2, the de Broglie wavelength increases by 50%. That is lambda 1 equals to lambda, then potential V equal to V1. Then lambda 2 equals to lambda plus 50% of lambda. Okay, that is, this is the lambda plus this is the lambda by 2. So this is the 3 lambda by 2. Okay, then V equal to V2. We have to calculate V1 by V2. Now you know the de Broglie wavelength lambda directly proportional to 1 by root under of V. Therefore, look at this. This is the lambda 2 by lambda 1. This is the root under of V1 by V2. Now, look at this, lambda 2 by lambda 1. Look at this. This is the 3 by 2. Okay. This equals to root under of V1 by V2. So, square of this becomes 3 by 2 the whole 3 by 2 whole square. So, this is the 9 by 4 is the ratio between V1 and V2. Okay. Next. In the given circuit, the RMS value of current IRMS through the resistor R is. We have to calculate the current IRMS. Now look at this. Here XL equals to 200, XC equals to 100, R equals to 100, and VRMS is equal to, look at this, 100 by root 2. Now we have to calculate the impedance Z. Z equals to, look at this, root under R square plus this is the XL minus XC whole square. Okay. Now look at this. Here R square means this is the 100 square. Okay. Plus look at this. XL is the 200 and XC is the 100. Therefore difference of this is the 100. So this is also 100 square. Therefore, this is the 100 root 2. Therefore, current I equals to, look at this, this is the VRMS 200 root 2 divided by Z. Z is the 100 root 2, therefore I equals to 2 ampere. So look at this, option 1 is correct. Okay, next question. Now question number 6. It is the very easy type numerical. Look at this, a thin prism P1 with an angle 6 degree is made of a glass of refractive index 1.54. So look at this, this is the mu1 is equal to 1.54 and angle of the prism, this is equal to 6 degree. Combined with another prism P2 made from glass of refractive index, this is the mu2 equal to, this is the 1.7. No problem. To produce dispersion without average deviation, the angle of the prism A2. Look at this. In the here case is the dispersion without deviation. Now dispersion without deviation is condition is mu1 minus a1 mu1 minus 1 into a1 plus mu2 minus 1 into a2, this equal to 0. Okay, now look at this, this is the combination, this is the combination. So here angle of the prism are opposite in sign. Look at this, first of all this is the 1.54 minus 1 into 6, okay, plus mu2 1.72 minus 1, and a2 is the negative sign because the refractive angle of the two prism are in opposite side. Therefore, look at this 0.72 into a2, this equal to 0.54 into 6. Now this and this is the 3 and this is the 4. So look at this, a2 equal to, this is the 18 by 4, so this is the 4.5. Understood? Now look at this question number 7. A block of root 3 kg is attached to a string where other end is attached to the wall. An unknown force AP is applied so that the string makes an angle of 30 degree with the wall. Tension T is. Now to calculate the tension, we have to resolve the tension in vertical direction as well as in horizontal direction. So this type of numerical, so this is a easy type numerical. Just to resolve T and equate the force along left is equal to force along right, and force in upward direction is equal to force in downward direction. Now look at this, this is the 30 degree. So look at this angle also 30 degree. So component of tension, look at this is the T cos 30. Now if we equate the vertical force is equal to this vertical force downward, you can get the tension. So this is the T cos 30 degree, this is the mass root 3 into G is the 10. Now T into this is the root 3 by 2 equal to this is the root 3 into 10. Now this and this cancel out. So T equal to this is the 20 Newton. Okay. So look at this question. So look at this, option 2 is correct. Okay. Next. Now look at this question number 8. A machine gun of mass 10 kg fires 20 gram bullet at the rate of 180 bullet per minute with a speed of 100 meter per second each. The recoil velocity of the gun, capital V. Look at this, if capital V is the recoil velocity of the gun, then momentum of the gun, this is the mass 10 kg into V. Now we have to calculate the momentum of the bullet. Now look at this. Now look at this. The number of bullet fired in 1 minute is 60. So number of bullet fired in 1 second. So number of bullet fired per second. This is the 180 by 60. So this is the 3. Now momentum of 3 bullet, this is the 3 into mass. Mass is the 20 gram. So gram should be converted into kg, and velocity, this is the 100. So look at this, the momentum of the gun is equal to momentum of 3 bullet fired per second. Now look at this and this cancel out, this and this cancel out. So this is the 6. Therefore V equal to 0.6 is the answer. Now option 2 is correct. Okay, next. Question number 9. Look at this. For a simple harmonic motion in a mass spring system, so look at this. This is the mass, this is the spring. The surface is frictionless. When the mass of the block is 1 kg, the angular frequency omega 1. Now, angular frequency omega 1, look at this. This is the root under force constant divided by mass of it. So, omega 1 is equal to, look at this, k by 1. When the mass of the block is 2 kg, angular frequency omega 2. So, omega 2 is the, look at this, root over, this is the k by 2. So look at this here, omega 1. So look at this here, omega 2 by omega 1. This equal to root under of 1 by 2. Okay. So, option A is correct. Understood? Next. Now look at this question number 10. As shown in the figure, a point charge Q is placed at the center of a conducting spherical shell of inner radius A and outer radius B. Okay, B is the outer radius. Electric field due to this charge Q at different region 1, 2, 3 is given by. Look at this, at Q charge at the center, here induced charge minus Q at this point and plus Q charge at this point. Okay, so look at this, in region 1 electric field is, look at this, in region 1 electric field E is equal to Q divided by 4 pi epsilon naught, this is the R square, where R less than B. Okay, where R less than A. Okay, so this is the E1. Now electric field in the region 2, look at this, in this region if a Gaussian surface is considered, the charge within the Gaussian surface is Q minus Q equal to 0. So electric field in the region 2 is equal to 0. And outside this region, the electric field, the and outside this region, the charge enclosed Q minus Q plus Q is not 0. So in the region 3, the electric field is equal to Q divided by 4 pi epsilon naught R cube, where R greater than B. Okay. So look at this. The options are here E1 and E3 are not 0 but E2 0. Option 4 correct. Okay. Now question number 11. The equivalent resistance between A and B. Look at this. From A and B, look at this. This is the 0.5, this is the 1.5. So look at this. This is the 2. Now this is the 12. Okay. Look at this. This is the 12. Now this and this are parallel. So this is the 8 into 2 in divided by 8 plus 2. So 8 into 2 divided by 1 8 plus 2, so this is the 1.6. Look at this, this is the 1.6, and 2 into 4 4 into 6 by 4 plus 6, so this is the 2.4. Again look at this, now it connected. Now look at this again, this is the 6 ohm, and again this is the 2 ohm. So look at this, these 5 resistances are in parallel. Look at this, this is the 2 ohm, this is the 12 ohm, this is the also, this is the 4 ohm, this is the 6 ohm, this is the 2 ohm. Now, so equivalent resistance 1 by R, this is the 1 by 2 plus 1 by 12 plus 1 by 4 plus 1 by 6 plus 1 by 2. Okay, these 2 parallel, these 6 parallel, this 4 parallel, this 12 parallel, these 2 parallel. Now what is the LCM? Look at this, LCM is the 12. So this is the 6 plus 1 plus this is the 3 plus 2 plus 6. Okay, 6 plus 2, 8, 8 plus 3, 11, 11 plus 11 plus 1, 12, 12 plus 6, 18. So R is the 12 by 18. That is 2 by 3. Okay. Look at these options. This is the 2 by 3 is the answer. Okay. Now assertion A. The efficiency of a reversible engine will be highest at minus 273 temperature at the cold reservoir. Yes. The efficiency 100% if 1 minus T2 by T1. This is equal to, this is the formula of efficiency. Now T2 equal to minus 273 degree plus 273. So this is the 0. So efficiency is equal to 1. Okay, no problem. Now next. So assertion 1 is correct. The efficiency of Carnot engine depends not only on the temperature of the cold reservoir, it also depends on the temperature of the reservoir too. Yes, this is the correct option. So assertion A and reason are both are correct, and it is the explanation of A. Look at this, both A and B are true and R is the correct explanation of A. So option 3 is correct. Okay, next one. Now question number 13. Look at this, a flask contains hydrogen and oxygen in the ratio 2:1 by mass and temperature 27 degrees Celsius. The ratio of average kinetic energy per molecule of the hydrogen and oxygen respectively. Look at this, the mean translational kinetic energy E bar is equal to 3 by 2 kT. It only depends on temperature. As temperature is same for oxygen and hydrogen, so ratio of mean translational kinetic energy of hydrogen and oxygen molecule is 1:1. Okay. Now question number 14. The output Y for the input A and B is given as, look at this. This is the A, this is the A, this is the B, this is the B, this is the B. So at this point, this is the A and B not. Therefore, at this point, this is the A and B not. And at this point, this is the A and B not and B not. So why is the, look at this, so why is the, this is the A and B not into A and B not and B not whole not. So this can be written as A and B not plus A and B not and B. Okay. So look at this. Suppose this is the A, this is the B, this is the A and B not, and this is the Y. Look at this. This is the 0, 0. If 0, so this is the 1. Therefore, look at this, 0 and 1 plus 0 and 1, this equal to 0. Now 0, 1. Look at this, 0, 1 means this is the 1. Now 0, 1, 0 plus 1, 1, 1. Now 1, 0. So look at this is the 1. Now 1, 1, 1 and 0, 1, 0. So this is the 1. In the same way, 1, 1 So this is the 0. Therefore 0 dot 0 and a 0, 0 and 1 0. So this is the 0. So look at this, option A is correct. Okay, next this question number 15. Look at this, as shown in the figure, a current of 2 ampere flowing in an equilateral triangle of side 4 root 3 centimeter. The magnetic field at the centroid O of the triangle. If a line is drawn from the vertex to centroid and centroid to the midpoint of the side, so look at this angle is 30 degree. Okay, so look at this, the distance of centroid, the normal distance of centroid from the side, this is the r. So r by half of the length. Look at this, side of the triangle is 4 by root 3, 4 root 3 centimeter. So half of the length is 2 root 3 divided by 100. This equal to tan 30 degree. Okay, now tan 30 equal to 1 by root 3. So look at this, r is equal to 2 by 100. Now look at this. So magnetic field B equal to, this is the mu naught by 4 pi. I means 2 ampere. R means 2 by 100. Okay, into sine theta 1 plus sine theta 2. Now sine theta 1, this is 30 degree. Now sine theta 1, if this angle 30 degree, this angle 60 degree. Okay, so this is the sine 60 degree plus sine 60 degree. Okay, therefore this is the root 3. Therefore look at this, this is the 10 to the power minus 7 into, this is the 10 to the power 2 into root 3. So, as it has three sides, so net magnetic field, this is the 3 root 3 into 10 to the power minus 5 Tesla. Okay, so look at this, the option 2 is correct. Okay, now question number 16. Look at this. Now question number 16. A current carrying rectangular lobe PQRS is made of uniform wire. Length of length PR and QS. Look at this. This length and this length is equal to 5 centimeter. This is the 5 centimeter. And this length, this is the 100 centimeter. Okay, this is the 100 centimeter. This length and this length, this is the 100 centimeter. If an ammeter reading changes from I to 2I, the ratio of the magnetic force per unit length of the wire PQ and RS, magnetic force on PQ and RS changes. Now look at this. This is the magnetic force FPQ is to FPQ when current is I and current is, this is the 2I. Now magnetic force F directly proportional to the square of the current of each. So look at this, when current is, this is the I by 2 and this is the I. So force becomes 4 times that of initial. Okay. As current, look at this, as current in the conductor, as current in both the conductor is twice the initial. So magnetic force is directly proportional to square of the 2. So this is the 4 times. Therefore options are 1 is to 4. Okay. Now look at this question number 17. Attenuations. Attenuation means loss of energy. Look at this, loss of strength signal while propagate through a media. Look at this, transducer is the energy converter. One form of energy to other form of energy. So this is the B. Okay. And this is the A. Now demodulation. Look at this, the process of retrieval of information. This is the C. And repeater is the combination of transmitter. Repeater is the combination of receiver and transmitter. Okay, it also contains an amplifier. So look at this, the correct option is, look at this, 1D. Look at this, 1 4. B2. Okay, look at this, A4. Look at this, A4, either 2 or 3. B3. Okay. C, look at this. C is the, look at this, C is the 2. So option 3 is correct. Okay. Now question number 19. Look at this. A point source of 100 watt emit light with 5% efficiency. So net light, look at this. This is the 100 by 5 by 100. Okay. Watt. At a distance of 5 meter from the source, the intensity produced by the electric field. So look at this. This is the, this is the total light. So amount of electric field, this is the half of it. So amount of electric field produced by this power, this is the 5 by 2. So intensity is the power by area. Okay, this is the 5 by 2 divided by 4 pi into 5 square. Okay, so look at this. I equal to, this is the 5 by 2 into, this is the 100 pi. Okay, so look at this. This is the 1 by 40 pi is the intensity produced by electric field. Now option A is correct. Now question number 19. A vehicle travels 4 km with speed 3 km per hour and another 4 km with speed 5 km per hour. The average speed. Look at this here, distance same. As distance same, so average velocity v is equal to, this is the 2 v1 v2 divided by v1 plus v2. Okay, so this is the 2 into 3 into 5 divided by 3 plus 5, this is the 8. Therefore 15 by 4, that is 3.75 is the correct option of average velocity. Okay, now question number 20. Given below are two statements, one labeled as assertion A and other labeled as assertion R. Now look at this, the nuclear density of nuclide, this. Okay, the nuclear density of all nuclides is 2 into 10 to the power 17 kg per meter cube. So this is false. The radius R of nucleus related to the mass number A. Okay, this is the correct option. So A false, R. So A false and R correct. Okay. So option C is, look at this, option C is correct. Understood? Look at this question number 21. In a young double slit experiment, the intensity of 2 points for the path difference lambda by 4 and lambda by 3 is I1 and I2 respectively. I0 denotes the intensity produced by each one, then each one of the individual slit, then I1 plus I2 by I0. Now first of all we have to calculate I1. As lambda by 4 is the path difference, so 2 pi by 4 is the phase difference. This is the pi by 2. As pi by 2 is the path difference, so as pi by 2 is the path difference, so look at this, I1 equals to I0 plus I0 plus 2 into root under I0 cos 90 degree. So this is the 2 I0. Okay. Now I3, now I2, look at this, as lambda by 3 is the path difference, so phase difference is 2 pi by 3. So look at this is the I0 plus 2 into root under I0 cos 2 pi by 3. Now cos 2 pi by 3 means minus half. So look at this is the I0. So here this is the 2 I0 plus I0 divided by I0. So this is the 3 answer. Okay. Look at this question number 22. As shown in the figure, a cuboid lies in a region with electric field E vector equal to 2 x square I cap, 2y j cap plus 3 k cap Newton per coulomb. The magnitude of charge within the cuboid is n epsilon naught coulomb. The value of n is, now look at this, the dimension of the cuboid is 1 into 2 into 3. So look at this, the area factor is equal to, look at this is the 1 into 2. This is the perpendicular to z axis. So this is the 2 k cap. Now 2 into 3, this is the 6 I cap, and 3 into 1, this is the 3 j cap. So area vector is the 6 I cap plus 3 j cap plus 2 k cap. Now electric field E vector at the origin, this is the only 6 k cap. So phi 1 is equal to E1 dot A vector. So this is the, look at this, this is the 6 k cap and 2 k cap. So this is the 12 voltmeter is the flux. Now phi 2. Now what is electric field vector E2? Look at this electric field vector along x-axis at x equals to 1. This is the 2 I cap. No problem. Electric field along y-axis, this is the minus 8 j cap. And electric field along z-axis, this is the 6 k cap. So flux phi 2, this is the E2 dot A. So look at this, this is the 2 into 6 minus 8 into 3 plus 2 into 6. Now look at this is the 2 into 6, this is the 12, 2 into 6, 12, and this is the 24. So phi 2 0. Therefore, q by epsilon naught, this is the phi 2 minus phi 1. So look at this is the only minus 12 voltmeter. So this is the minus 12. So q equals to minus 12. So n equals to minus 12. Okay. Look at this, a body of mass 2 kg is initially at rest. It starts moving unidirectionally under the influence of a source of constant power P. Its displacement for second is this. We have to calculate alpha. Now look at this. For constant power, force into V is equal to power constant. Now force, this is the mass into dV by dt into V, this is the P. Now mass is equal to 2 kg. So look at this, V dV, V, this equals to P into dt. Now integrating, this is the, okay, 0 to T, this is the 0 to V. So look at this is the 2 into V square by 2, this is the P into T. So look at this cancel out. So V equals to root under P into T. Okay. Now look at this is the ds by dt, this equal to root over P into T to the power half. Okay. So look at this is the ds is equal to root over P into integration of T to the power half dt. Okay. Look at this is the 0 to S and this is the 0 to T. Now look at this is the S equal to root over P. Look at this is the T to the power 3 by 2 by 3 by 2. So look at this is the 2 by 3 root over P into T to the power 3 by 2. Now T is equal to, look, 4 seconds. So look at this is the 4 to the power, this is the 3 by 2. 4 to the power 3 by 2, this means 8. So this is the 8 into 2 by 3 root over P is the displacement. Now look at this 1 by, so look at this is the 1/3 alpha square root over P. So alpha square is equal to 16. Therefore alpha equal to 4. So 4 is the answer. Okay. Look at this, a stone tied to 180 centimeter long string at its end making 28 revolutions in a horizontal circle in every minute. The magnitude of accretion of the stone. Now look at this, accretion equal to omega square into r. Now what is omega? Look at this, 28 revolutions in a horizontal circle in every minute. Therefore, omega is equal to 2 pi into 28 by 60. This is whole square into radius is the 180 centimeter. This should be converted into meter. So this is the acceleration. Now look at this. This is the look at this. This is the 2 into 22 by 7 into 28 divided by 60 whole square into 1.8. Now this and this cancel out. So this is the 4. This and this is the 15. Therefore, look at this. This is the 44 into 44 divided by 225 into this is the 1.8. Okay. This 1 by x is equal to 1.8 by 225. Therefore, x equals to this is the 250 divided by this is the 18. Now, this is the 9. 9 means this is the 2 and this is the 50. Okay, so this is the 25 is the correct value of x. Okay, look at this. A uniform disc of mass 0.5 kg and radius are projected with velocity 18 meter per second at t equal to 0 on a rough horizontal surface. It starts off with a purely sliding motion at t equal to 0. After 2 seconds, it acquires a purely rolling motion. The total kinetic energy of the disk after 2 seconds. Look at this. So V equal to this is the initial velocity 18 minus A into T. What is retardation? Retardation is the A equal to minus mu mg by m. That is the mu g. Mu is the 0.3. A is the G is the 10. So look at this. This is the 0.3 into 10. So this is the 3 meter per second square. So look at this 12 minus 3 into 2. That is this is the 6. That is 12 meter per second is the final velocity. So total kinetic energy. This is the half mv square into 1 plus k square by r square. Okay. Now look at this half mv square. This is the half into 0.5. Okay. Into v square. That is 144 into 1 plus k square by r square. For disk k square by r square. This equal to half. So look at this. This is the 3 by 2. Okay. Now look at this. This is the 1/4. So look at this 144 into 3 divided by this is the 2 into 4. Now this and this is the 36. This and this is the 18. Therefore 72 joule is the total kinetic energy. Okay, so this is the 72 is the answer. Now question 26. If the potential difference between B and D is 0, that is potential at B is equal to potential of B. So it is a balanced Wheatstone bridge. Now resistance of this branch, look at this is the parallel combination. So 6 into 3 by 6 plus 3. So this is the 2 ohm. Divided by this is also parallel combination. This is the x into 1 by x plus 1. This equal to look at this is the C combination. This is the 3 divided by x. Okay. Now look at this is the 2x equal to 3x divided by x plus 1. Now x and x cancel out. Therefore twice x plus 2 this equal to 3. So x equal to half. Look at this x equals to half equal to 1 by n. So look at this n equal to 2. Okay. The velocity of a particle of SHF varies with displacement x as, look at this. This is the 4v square equal to 50 minus x square. So look at this v equals to, this is the half of root over of 50 minus x square. If we compare this with omega into root over of a square minus x square, here omega equal to half. The time period of oscillation t equal to x by 7. So t equal to this is the x by 7. Now t equals to 2 pi by omega. 2 pi by omega means 2 pi by half. This is the x by 7. Therefore, x equals to, this is the 28 pi. Now, this is the 28 and pi means 22 by 7. So, this is the 88. Therefore, 88 is the value for x. Okay. A faulty thermometer reads 5 degrees Celsius in melting ice. Look at this. Therefore, lower fixed point is 5 degrees Celsius and 95 at steam. That is upper fixed point. Upper fixed point, this is the 95. The correct temperature at absolute scale will be when faulty thermometer reads 41 degrees Celsius. Now look at this. We have to now look at this. For a Kelvin scale, K minus 273 divided by 100. This equal to, this is the 41 minus lower fixed point. This is the 5 divided by upper fixed point minus lower fixed point. So look at this. This is the 36 by 90. Now this and this cancel out. This is the 5 and this is the 2. So look at this. K minus 273 equals to 100 into 0.4. That is 40. Therefore, K equals to, this is the 273 plus 40. Therefore, this is the 313 is the correct answer. So, this is the 313. Okay. Now, question number 29. In an AC generator, a rectangular coil of 100 turns, each having area 14 into 10 to the power minus 2 meters square, is rotated at 360 revolution per minute about an axis perpendicular to uniform magnetic field 3 Tesla. The maximum value of EMF produced. Look at this, the maximum value of EMF produced. This is the N, B, omega A. What is N? Look at this, N is the 100. B is the, look at this, B is the 3 Tesla. And omega is the, look at this, 2 pi into frequency. Now frequency is the 360 revolution per minute. So this is the 6 revolution per second. So this is the 6. Area is the 14 into 10 to the power minus 2. Now look at this. This is the 300 into 2 into 22 by 7. Okay. Into 6 into 14 into 10 to the power minus 2. Now look at this and this. This is the 2. No problem. Okay. This 2, 0, this 2, 0 cancel out. Therefore, you get, this is the 6 into 22 into 6 into into 2. Therefore, look at this. This is the 72 into 22. Now, 72 into 22. Look at this. This is the 144, 144. So, this is the 1584 volt is the EMF induced. 1584 volt. 1584 volt is the EMF induced. Okay. Look at this, a radioactive nucleus decays into two different nucleus. The half-life of first process is 5 minutes and that of second process is 30 seconds. The effective half-life of the nucleus. Look at this, the decay constant of first is lambda 1 and that of lambda 2, then net decay constant lambda 1 plus lambda 2 equals to lambda. Now look at this is the 0.693 T1 plus 0.693 T2 equal to 0.693 by T. So look at this cancel out. Therefore, this is the 1 by 300 plus 1 by 30. 5 minutes means 300 seconds equals to 1 by T. Okay. Now look at this. This is the 11 by 300. Okay, equal to 1 by T. Therefore, T equal to 300 by 11. So look at this. This is the alpha by 11. Therefore, alpha equals to 300. Okay. this paper will be slightly calculative and based on concept. Okay, hope this discussion will be extremely helpful for you. Please like and share the video. Okay.